Hi everyone, I'm Julian. In this video, I'm going to discuss the partial write-up for Lab 2 Stream Survey and talk to you about how to get started with the R script in RStudio. Before you watch this video, please read the Lab 2 file and watch the associated video so that everything here makes sense. So we're going to start by logging into Brightspace and then going to Biology 2600. And under Lab 2, you will see a bunch of files. So the first thing you're going to do is open up your stream survey file and read it. And then you're going to watch the video. And then you're going to do your assignment. So this is your stream survey file. So you're going to read all this background information. Nice picture from your textbook. This is the sampling procedure that would have normally been done if we were on campus. And you get down here to the assignment part. So you're going to be handing in a partial lab report, which is different from a full lab report in that all the sections are not contained. So the only sections that you need are in bold down here. I'll go for them in a second. So you're also provided with our code, stream lab code, and I believe your file says YRT at the end. And this code is going to be used to calculate your organism average densities, your means, and to generate your graphs. So you're going to run through those, input your sample data, your CSV files, and then go for that. So I'm going to talk about that in detail in a second. I'm just going to cover the other sections first. So your title should be specific. What was done, when was it done, where was it done. So you did, a stream survey, invertebrate stream survey was done. It was done in fall 2020, and it was done in the stream perpendicular to Bennett's Road in Portugal Cove, St. Philip's. So your tables 1A and B are your organism tables. You're going to complete your average density with R&R Studio. Like I said, I'll talk about that in a second. And then these tables are going to go in your appendix. So they are the files that are called organisms_pool and organisms_riffle. And so you see we have the densities calculated for each of the groups. The mean is missing. We're going to calculate this with R. And then this table goes in the appendix of your report. Tables 2A and 2B, once you calculate the means using R, are going to go in your results section. So these are your abiotic pool and abiotic riffle tables. So you have average depth and water velocity. Again, you're going to calculate your means with R&R Studio, and these are going to go in the actual results section. So table 1A and table 1B. So that's this part. You're going to hand in 1 or 2 bar graphs. This depends on how you make it. So you're going to have the density of organisms for the stream and for the pool and for the riffle. So if you want to include both of those in one, you can. If you want to make a graph for each one, you can do that. Entirely up to you. That's why you might have one or two graphs. So you should have your taxonomic groups, and these are the names straight from these files right here. Along the bottom, so your x-axis, and your y-axis will be average organism density and organisms per centimeter squared. You're going to need a title. Again, it should state specifics, what was done, when and where, and label your axes, key or legend if necessary. This is all going to be in R, so we'll talk about that in a second. You need a brief summary, so brief summary. just highlighting the major results. So which orders are dominant in the pool, which are dominant in the riffle, are some equal. So you're just stating the trends, and also do not have any explanation here. That's going to be in the discussion. In your discussion, a super brief statement just says, based on the results in figure 1 and 2, your graphs, the main findings is going to be pretty much the same thing as this. And then this is gonna be the hardest part. So you're gonna give reasons as to why certain organisms are more prevalent in the riffle or the pool. So as is discussed in the file and in the video, these are the pool and the riffle are two different environments, and there's different abiotic factors which exist in each one, and organisms are going to be adapted to specific abiotic factors, so that's why they should be more prevalent in one or the other environment. So you need to list 3 of those abiotic factors. There's a summary slide right in the video which lists all of them. So substrate bottom, temperature, oxygen concentration, water velocity, sunlight, and there's a couple more, but there is a summary slide right in the video, as it says right here. And then you're going to explain, so you're going to need to do some additional background research and explain why this organism exists in the pool. So for example, if you were to look up Trichoptera, so you Google Trichoptera, if you find it happens to be occur in a pool, so you go Trichoptera fast water flow, and you should be able to come up with some sources. Or you go pool, or you go high oxygen concentration, and you should find something that says this organism prefers high oxygen concentration. If it does, then it should be found in the riffle because that has a higher oxygen concentration. So that's explaining why one organism or one group of organisms exists in one area as opposed to the other. So that was just an example. I don't know if that's true. You'd have to look that up. If you have any questions on this, just let me know. Keep in mind you should cite any information that is not yours. And then you're going to have a little blurb on experimental procedure. So discuss one problem and one potential solution. So it could be anything of, well, this was only done in one pool or one riffle, that might lead to bias. Maybe the same person was picking at the rocks and they had a certain preference. It could be anything along those lines. So not human error as in so-and-so couldn't do the measurements right. It has to be assuming everything was done correctly, how could this procedure or experimental design be improved? And then you're going to have a reference section. So this file is the same file that's uploaded to the literature assignment folder. So you're going to use the exact same formatting for that. Let's bring it up here. So this is the file here, exact same file. This is how you do your citations. This is how you cite different references in your reference list. And that just goes at the end. The last thing you're going to include is the R code. So once you generate the code to get all your data or calculate your stuff and make your graphs, you're going to include a copy of this code. The purpose of this is if your graph doesn't look good or if your means are calculated incorrectly, then we are not going to deduct a lot of marks because it's probably due to a simple error that you made in your code. So, and I'll talk more about that in a second. So let's do the R stuff. So if we go back to Brightspace in Lab 2, you're going to see all these files. So this is the code. This is the file that you're going to open with R. These are the two files that I already showed you, the abiotic characteristics. This is the organisms in the pool, organisms in the riffle, and Dr. LaRue uses these two files to give you an example of how you would actually make your graph. So just so the graphs appear nicer, the organism names were abbreviated here. So this is, in case you're wondering what the organism is, this file contains the abbreviated names, and this is the citations reference file which I mentioned. So you want to download all of these files, so your code and your 6 files into one folder. So one thing you want to do is download all your files into one folder. So these are all the files that you need here: your stream code, organism riffle and test, organism pool and test, and your abiotic pool and riffle. So if they're in one code, it makes it easier for R to find it. So we're going to start with, let's get rid of that. We're just going to double click this and it should open up in R. So this is what you get. This is your source pane. So all this here contains your source code. This is your console pane, which is where you execute or run your code. The files that you import are going to appear down here, and your graphs are going to appear down here. So essentially you're going to use this file, commands that are already in this file, to put in here, and then you're going to run them, and it's going to import files and generate your graphs. So everything that starts with a hashtag and is in green is just information for you to know what the following or the next code that appears in black means and is. So for example, this one is going to clear your workspace, and you can do this at any time. So you copy it from here, paste it over here, hit enter, and if you have files here, they'd be cleared. So then you go down here. So hashtag, you're going to import your data. So these commands, the first command here is to import your data. So you select it, copy it, put it down here, hit enter, and right off the hop your file appears here, and you can click on it, and sure enough, this is the file, and you can close it out. It's going to stay down here. So one issue you might have is if your files are not in the same folder as your code, or for some other reason, our studio cannot locate your folders. There's one thing you can do. So to find out where R is looking for your files, you type get wd, which is get working directory, 2 brackets, and hit enter. So this is the location where R is looking for the files. So that location should be the same as where your files are. So if you right click and you go down to properties, right here you can see location, and so the reason R found my file is because this location here is the exact same as this location here. If for some reason it's not, that may explain why it's not finding your file. And to fix this, you would go equals set wd, and you got to put in some quotation marks, find your file, and you can just go copy that, put it in here. Make sure you always put your cursor at the end, and you have an error. So this is part of the fun. Well, there's one, shouldn't have an equal sign there, and set is not spelled correctly, so that's 2 errors. And the other one that I can pick up is these slashes go the other way compared to the ones down here. So if I copy this, I can put it down here, and then I'm gonna change the slashes to make sure that they line up with this. Put your cursor at the end, hit enter, and that worked. So now your working directory is set. So this can be whatever, wherever your file is. And then when you go load your file, it should load down here. So these are some ways to check your file down here. You should go through them to make sure everything's okay. Then you're going to import this one, you're going to check them, import these two and check them. I'm not going to do that because it's the exact same thing. And so for now, Dr. LaRue uses two other files to show you how to calculate everything. So first thing you do is import, and you get a warning message. So no need to panic. So this is the file we opened. So when you look at it, the file looks fine. So I'm not going to tell you what is causing this, but if you can find out what causes this error and you put the solution in your report in the code, you'll get a bonus point. And if you don't, no worries, because everything will still work. So you import that file, you have your code right here to calculate your mean, put that in, hit enter, nothing happens, or it doesn't look like anything happens, but when you click on this, now you can see that means are calculated here. So that's 2 steps done, and you can check your file just by typing in this. And then down here you have the codes to make your graph. So I'm just going to do one of these. You go Control C and hit enter. So you may get this error. And that's because the window down here is pretty small. So if you make your window bigger just to get your graph, and then you paste in that exact same code again, you end up getting a graph. So if these are cut off a little bit, that's fine. They shouldn't be cut off in the actual files that you use, because I specifically abbreviated the name so that they're shorter. And even if they are a little cut off, as long as you get your graph, it should be fine. One thing I will mention, and so he talks about how to make, you can make this graph for pool, one graph for riffle, you can make them both side by side, and then you can actually make them together. What you decide to do is up to you. All the instructions are right here, you just copy and paste over here. So, and when you get to the bottom, so that is the test data. Now you're going to do this for your actual data. So one thing you're going to have to change is the organism names. So here it only lists 3 organism groups because that's the test file. In your file, which is down here, you're going to have to type in each one of these, or you don't have to type it in, you just copy and paste it in here. Make sure each one has quotation marks around it and there's a comma in between, and then you do your next one. And so once you do that for one file, you can just use your code for the second file to get your figures. You're gonna get fun errors like this, and that's, and by fun I mean frustrating. So don't be frustrated. So if you were just to copy this and then you open up Google and you type it in Google, it just gives you several ways to fix that. It definitely tells you what it means, and if you look a little bit harder, you can find ways to fix it. So it is frustrating. for me as well, for Dr. Earl. Like this is going to happen to everybody. Don't be frustrated. Jacob's going to be around for questions. I'm going to be here for questions. You can email Dr. LaRue. You can Google it. Any issues, just let me know, or one of us know, and then we'll help you out. Last thing I will say is, so the code that you end up using here, you can either save this file and that'll contain your code, or you can just go, well, you can't do anything. You could just, you can just select all that. You can copy it into a different Word file and save that, add that to the end of your report. There's a number of different ways you can do that, as long as you provide your code.